Hey guys, today I'm going to go over how to do the 11.1 activity, balancing chemical equations. So the first thing I want to show you is a fully balanced chemical equation, and this here is the chemical equation. This is potassium dichromate, and this breaks down to form potassium oxide, chromium 4 oxide, and oxygen. So there's a couple things to notice about this. So here is my potassium dichromate molecule. And what happens to this molecule, that's actually a formula unit, it's not a molecule, there's not covalent bonds, I'm sorry, but this compound, what happens to it is it's going to break down, and I'm going to show you that process right now. So check out this sweet animation. Alright, so my potassium dichromate is going to break down to all of these things. Now, the biggest thing that you want to notice in this is all of the atoms that were in our reactants are found in our products. So let's make sure that's true. So let's start with potassium, or K. You want to hear a joke about potassium? K. Anyways, all right, so in my 1 potassium dichromate here, I have boom, boom, 1, 2 potassiums. And then in my products, I have boom, boom, 2 potassiums. So I didn't create or destroy any potassium, so that follows the law of conservation of mass. Let's look at the chromium, Cr, 1, 2. Rearranges, and I still have 1, 2 chromiums. So I didn't create or destroy any chromiums. How about oxygens? Oxygen had 1, 2, 3, 4, 5, 6, 7. It rearranges, and in the products, I find 1, 2, 3, 4, 5, 6, 7. So oxygen, all the oxygens reacted to go into the products. You don't have any extras. Everything's used perfectly. So what's the big deal? Well, I have one of these potassium dichromates. And in the product, if you notice, I have 1 potassium oxide, but I have 2 chromium 4 oxides and only 1 oxygen molecule. And that's shown by up here. If you notice, I don't have any number in front of my potassium dichromate formula. That means I just have this, which is 1, which is understood. In my potassium oxide, you don't see a number in front, and it's understood just to be one of them. If you say, I have potassium oxide, you know that that's one of them. But if you need to have more than one, you need to tell your reader. So that's why this 2, it's called your coefficient, is there. So I have a 2 here as my coefficient in my balanced chemical equation because I have not just 1 CrO2, but I have 2 CrO2 molecules. And then my O2, I just have one of them, so I don't have a number there. All right, so here's one of the pages from your activity today, so go ahead and open it up to this page. We're going to do number 1 together right now, so you'll actually get the answers here. I'll talk you through how to do it, and you'll move on to number 2. Now, the other stations are set up for 2 through 6. There are colors that are recommended. If the colors aren't exact what they are in the station, just come up with your own key. So if there isn't any blue for oxygen, but there is an extra purple PlayDough, then use purple, and that's fine. Just make sure you're consistent with the color for each station. So, all right. At each station, you're going to see a green sheet of paper, so that's why I went ahead and made the slide green, so it kind of matches. And I'll move this picture up here. All right, so for the first problem, it's iron plus sulfur, and sulfur in elemental form is S8. Makes iron 2 sulfide. So if I just drew the atoms for this, and the way you're going to do that is by making atoms out of Play-Doh, here would be my iron. Notice it's just Fe, just a single atom, because if I look at the formula, it's just Fe. There's no subscripts. But for sulfur, sulfur is actually 8 sulfur atoms bound together. Now you don't need to make the proper geometric shape or anything. You just need to have 8 circles put together. So 1, 2, 3, 4, 5, 6, 7, 8. So this is my S8. And that's going to, these are going to rearrange to make this. Now, when you think about a chemical equation, I want you to think of this yield sign for right now as being let's look at these as two totally different things, and they have to kind of be equal to each other. Because in my other equation, if I had drawn a big bar, I could have compared, do I have the same number of chromium atoms on each side, and so on and so forth. So if I look at this, I don't have the same number of atoms on each side. So it's almost like if you put them on a scale, my reactants is way more massive than my products, and that can't be true. You have to have the same amount of mass to start with as what you end with. So this can't be right because you can't have this be a lot more stuff than here. You have to end up being equal. So we're going to need to add things so you have the equal number of atoms to start with and end with, since we can't create or destroy any atoms. So I can't just say, oh, 7 of these sulfurs just went away. That doesn't happen. Molecules and atoms, they can't go away, they can't be destroyed. So if I want to balance it, I mean, I could just say, woo, well, let's add some 7 more sulfur atoms. But that doesn't work. And the reason it doesn't work like that, I cannot do this, is because my FES is what I have as my compound on my product side. So that's the only thing you can add. You can only add another FES. So let's try that again. So instead of adding just sulfur, I can't. I know I need 7 more sulfurs, but I need to add FES each time. So I'm going to add 1, 2, 3, 4, 5, 6, 7 more. So I have 8 total FESs. And this is going to balance out my sulfurs. So that means each sulfur is going to react with 1 iron. But the weird thing about this, if I look at it, I only have 1 iron to start. Where did those other irons come from? Meaning I had more irons in my initial reactant. So 1, 2, 3, 4, 5, 6, 7 more, in fact. So this is now balanced. I have 8 irons on the reactants, and I have 8 irons on the products. I have 8 sulfurs in the reactants. I have 8 sulfurs in the products. It won't always be the same number of atoms of all of your reactants and products, all of your elements, but this one's just an easy one to get you started. The key thing is you have to add what's in the formula up here. So to finish up, to make your balanced chemical equation, so that's what I'm looking for at the end, you're going to draw this picture in the open space provided in color. I have colored pencils for you in the classroom. And then you're going to add your coefficients, and that's the big deal. So how many irons do you have? Well, you have 8. So you have to put an 8 in front of Fe. Coefficients always go in front of the whole molecule or formula unit. You cannot put them in between. You can't change the subscripts. You can only add a big number in front. So that's not the only thing we changed from 1. We still only have 1 S8, but now we have more than 1 FES, or iron 2 sulfide. We have, if you count this up, you have 8 of them. So that means you have 8 of this thing, so you put an 8. And this is your balanced chemical equation. So this is what you're going for. This is the final answer. All right, so good luck with the activity. Have fun.